Hi guys, today I'm going to explain you how pipelining is being used in RISC processor and how to design the pipeline circuit in Verilog code. For example, let's consider a simple architecture of the RISC processor, that is reduced instruction set computer. The first module fetches the instructions, second module decodes the instruction, the third module executes the instruction, and the fourth module it accesses the memory, and the fifth module writes back the data. So what is pipelining in this processor? Pipelining is nothing but when you consider a CISC architecture, a particular task is executed in a particular cycle, that is the time cycle. For example, there are four tasks over here, and let me explain here. See, the time represents the cycle, number of cycles, and the tasks are ABCD. There are four tasks to be executed over here. When you consider a CISC processor, each task, that is for example A is executed in the first cycle, B is executed in the second cycle, the task C is executed in the third cycle, and the task D is executed in the fourth cycle. Whereas when you consider this pipeline RISC architecture, in every cycle all the tasks have been executed. For example, consider the first module. The output of the first module is given to the input to the second module, and the same thing, the output of the second module is given to the input to the third module, and so on. Here you can see task A, B, C, D. All the four tasks are being executed in the same cycle. That is why it's called as pipeline. Each task is been pipelined to the previous task, so it is in a queue. So now let's design a Verilog code like pipelining for the first module, that is the fetch instruction, using the mux and the gates as well as the program counter. Here the input to the program counter will be the output of the mux, and the which is the input to the program counter, and the clock signal and the output of the program counter. So let's go for it. Let's create a new source Verilog module pipeline. Let's give the input, that is we are designing the pipelining code for the first module, that is the mux and this access memory, address instruction memory. So there's a clock, there's an input, as in there's an output, and there's a reset. So let's go for it. There's a clock, there's a reset input, and the input that is from the, so we can take the input from the mux to be like the output of the mux is given to the input to the program counter. So let's take it as input 1. So then the output is output of the program counter out, and both these are 32-bit because the processor that we saw is a 30-bit processor. So input this is 32-bit, so 31 is to 0 input, and the output is, sorry, there is an output out, this is also 31-bit 32-bit, sorry. So next, and we declare a register 32-bit. Now to store the values. This is the previous errors. Okay. Next, always at positive edge of the clock or pause edge of the clock or negative edge of the clock, the output changes, the output triggers. Or pause edge EDG of reset, the output changes. So begin if reset is equal to 1, the program counter is reset, so the output will be output is equal to 0. The complete program counter is reset to 0. Else output is equal to the input from the, that is the input 1, which is the output from the mux end, and then end module. This is a simple pipelining structure which I showed in the Verilog module. You can design for each stage that there are 5 modules. For every module there will be a pipeline code, so you can design it seeing that. Thank you guys, hope you understood. Thank you so much.